Hello and welcome to today's Daily Killer Sudoku. It is November the 6th. Right, this one is difficulty 5, so it should be achievable. Let's give this a go. Alright. So, because we know nonets, which is the 3x3 squares, add up to 45, then this square and this square have to be 10, but we can't really work that out just yet. We can put 1 and 3 in there because that's the only combination for 4. We can do cage integration in this nonet. 17, 27, 38, so at least 7 left over, which means that's 1. Okay, and we can also do cage integration here with this 1. So 11, 12, 34 plus 19 is 53. 53 minus 45 is 8. And therefore that is 2 because these two add to 10 as we worked out before. That is 8 because 10. That means these two, because they can't be 6 and 8, the only other combination is 5 and 9. This 8, the only combination possible is 2 and 6 because 1 and 3 are both taken. And that leaves 4 and 7 for these two squares. 4 and 7 is 11, 12 minus 11 is 1. And we can also now work out, using cage integration, this square here. So we've got 1, 12, 24, 48. So 3 left over. And these two are 1, 2. Except this one has to be 1, and this is 3. Because 1 and 3, and 3 is taken there. Now we can also do cage integration. 13 for this nonet, 13, 33, 37, which leaves 8 left over.
This is SBS Chill. World music.
Yep, we've got SBS Chill on in the background. It's quite pleasant. What else can we do here? Okay. Looking at this nonet, the number 3 is taken for these two rows, and also this square here, which means the only place left to go is there. And so we can work out that that is 1, and that is 3. Let's see. For this nonet, again, the digit 2 taken in this column and this column. So it can't go in this square because 12, that would have to be 10, which means it has to go there. That makes 5, and to get to 11 we have 6. This nonet, digit 1 is taken in these two columns, and this square also by that, so it has to go there. Alright, what else can we do? Okay, this 10 here, because of the digits here, we know it can't be 1 and 9, 2 and 8, or 3 and 7, so it must be 4 and 6. Cage integration, we can work out this square here. So 36 plus 18 is 54, which means that is 9. And similar to this, 1, 3, and 8, so it can't be 1 and 9, 2 and 8, 3 and 7, so they must be 4 and 6, which means these squares left over have to be 5, 7, and 8. Rightio. What else can we do? In this row, the only digits left are 2, 5, and 7, so we can work out, we can put this one as 5, 7, 2 and 5, and this must be 2, 5, 7. We know that 2 must be one of these, so the combination is either 2 and 5 or 2 and 7. 2 and 5 is 7, so that would leave 6 left over. 2 and 7 would make 9, so there's 4 left over. But 6 is already taken, so we know that it must be 4, which means that this combination must be 2 and 7. Oops. Okay, and that must be 5. let's look at this cage here. So it comes to 24, and we've got 5 and 3, which is 8. 24 minus 8 is 16, so these two must be 7 and 9. Which means these two squares are 4 and 8, but because there's an 8 here, we put 4 there and 8 there, which means 4 must go there and there. Okay, very good. What else? That can't be 8 because we've got that there. These squares must be 5, 6, and 9, so that's 5 and 9 because of the 6 there. These two, 5, 6, and 9. Right. This column here, we draw 1, 2, 3, and 4 is the last digit remaining for this column. Looking at this column, 1, 2, 3, 4, so there's 5, 6, 7, 9 left over. In this column, there's 1, 2, so we have 3, 5, and 9 left over. It doesn't really help us. Okay. This cage here, 11, can't be 2 and 9. It can't be 3 and 8 because 3 and 8 are both taken for this thing, this square. Can't be 4 and 7, so it must be 5 and 6. This cage here, the 10, can't be 6 and 4, can't be 7 and 3, and it can't be 8 and 2 because of this. So it must be 1 and 9, and because there's a 1 down here, 9 goes there, and 1 to the left of it. Okay, because of the 4 here, we can take the 4 out there, which is at 6, and there we are. So that can no longer be a 6. And that can no longer be 6, so it's 5, and 6 to the right of it. Alright, in this nonet, 4 can only go in this square because it's taken in these two columns. So 4, and the digits remaining are 2, 3, and 8. 2 is taken in this column, so it must go there. 8 takes up this square, so that must be 3, and 8 is left to go there. Okay, we're making good progress. In this row, 3, 8, and 9 are the lost digits remaining. 3 and 8 are taken, so that must be 9. Therefore, that is 5, that's 9. What else? So 3 and 8 remaining in this row. 8 there because of the 3 here, and 3 there. In this row, second row, the 3 can't go in these 3 squares or this square because 3 here, so it must go there. The only digit remaining left in this column, column 1, is 5. And in these 2 squares, the last remaining digits are 6 and 7. Now, because we've got 8 here, we know that these 2 squares must add up to 11. I think we can work it out. It can't be 9 and 2, can't be 8 and 3, can't be 5 and 6, so it must be 4 and 7, which means that must be 6, and that must be 7. The only digit remaining left in row 1 is the 2, which makes 9 there for the cage. 1, 2, 3, 4, these 2 must be 5 and 6. looking at this column H, 5 is there, so that must be 9. And that must be 5, therefore, which leaves that is 6. Let's see, that can't be 5. That can't be. Oh, goodness. That can't be 5. So that must be 5. Leaving 7 in these two, which means that can't be 7. It must be 9, and that is 7. Alright. In this column, column 7, 1 and 9 are the less remaining digits. 9 is taken there, so we'll see 1, 9, and in the cage there's 8 left over. So that goes there, and the only digit remaining in that column is 3. Alrighty, in this nonet, it's completely blank, surprisingly. We can work out that 9 can't go in here, 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 or here, which means it must go there. That doesn't give us anything else immediately. But we can work out the row, this row, row 4, has the remaining digits 2, 5, and 7. 2 and 5 taken there, that must be 7, which means this square must be 8, that must be 7. This must be 4, oopsies, that must be 7. This must be 6, that must be 4. Alright, that must be 5, that must be 6. In this nonet, again, 3 is taken up in these two columns, and so it can go there or there, but the 3 is taken there, so it must be there. In this column, the only digit remaining is 6, that must be 2, that must be 6. So we've got 1, 2, and 5 left over. Actually, let's look at this nonet and column. There's 2, 5, and 7 left over. Looking at this row, well, you see the middle row has 5 and 2 taken, so that's 7. This square and this square, therefore, are 2 and 5, but we don't know exactly which yet. And in this row, also must be 2 and 5. This row, the only digits remaining are 4 and 8, and because the digits are shown there, we have 4 and 8 there. We'll have to do some maths here. Actually, this will be fine. So we've got 9, 8, 7, 6, which is 30, plus 30 plus 4 is 34, which leaves 2. And that's 5, 2. So we have 1 and 5 left over. That must be 1, that must be 5, that must be 1, and that must be 2. How about that? 30 minutes, 17 seconds. That is not bad. Okay, thank you for watching. I'll be back tomorrow.